Hello everyone, a warm welcome to the past, present and prospective students of Techno Engineering College Banipur. Today in this podcast I am going to talk about how to choose the right database technology for your project. Nowadays, irrespective of the engineering department you belong to, whether it might be computer science and engineering or information technology, it might be electronics and communication engineering, or it might be mechanical engineering. Sometimes and somehow you have to use database technology. For that part, database management system has become an integral part of the course curriculum for most of the departments. There are more than 300 database management systems available on the market. So, choosing the right one for your project is really a daunting task. You have an overwhelming number of options in front of your eyes, from where you have to choose the suitable one for your project, and you have limited time to do so. The first step should be to figure out the popular database technologies available in the market for which you can get enough support in terms of development as well as maintenance. There must be enough number of users for that database technology so that you can get community support as well. As of the day, some of the top database management softwares are Oracle, Microsoft SQL Server, SQLite, PostgreSQL, Amazon RDS, MongoDB, Redis, PHPMyAdmin, Hadoop HDFS. For most of the products, there are both enterprise editions as well as free community versions available. You can try the community versions for your own college projects to get your hands on them. Now come the big questions. From where do the data come? How much data you have to handle? What is the nature of the data? Nowadays, data comes from every segment of our life. It might be banks, toll plazas, railways, airlines, social media, or any other industry. Everyone is producing data. Here are some examples. State Bank of India has almost 420 million customers. Through Gurgaon Delhi Expressway toll plazas, around 180,000 vehicles pass daily, and the details of each passing vehicle must be updated without any error. On Facebook, 350 million photos are uploaded every day, with 14 million photo uploads per hour, 243,000 photo uploads per minute, and 4,000 photo uploads per second. So, the big question is how much storage you actually need. And the second question is how fast you have to process those data. For example, loosely speaking, in case of Facebook, all the 4,000 photos must be updated in the appropriate user account without any error within a few seconds. The next big question is whether your data is structured, semi-structured, or unstructured. An example of structured data is a transaction carried out in a bank. In case of semi-structured data, the data cannot be stored in the form of rows and columns. A source of semi-structured data can be email. Examples of unstructured data might be web pages, images, videos. If you are a detective and want to mark the criminals from social media comments, then you might have to pass all the comments available on that through some complex algorithms to figure out the criminal activities, and you have to do this in a limited amount of time. Otherwise, the criminal will fly to Las Vegas with all the money. Hence, in a nutshell, your problems are how much capacity do you need? In other words, can you accurately estimate a database's capacity? Second big question is how much processing will be there? Do you need to run multidimensional complex queries or complex algorithms on your database? Take an e-commerce order database as an example. Each subsystem needs to filter data by buyers, sellers, order status, and payment methods. Third question is, how much queries are you going to make per second? For example, in your college project, you make a few queries per second. Whereas in industrial scenario, if you take the example of State Bank of India, the number of queries will be in thousands per second. And above all, the ultimate question is your budget. How much money you want to spend on your database technology. Now, let us look at some trends. Trends are equally important because based on trends, you can figure out how much community support might be available there for a technology. Now, come to the actual technology itself. You can use SQL as well as NoSQL database for your project. I will not dive into much detail. It is beyond the scope of this video. Just will provide a quick introduction and some statistics. SQL databases, also known as relational databases, define and manipulate data based on structured query language. These are most popularly used and useful for handling structured data that organizes elements of data and standardizes how they relate to one another. On the other hand, we have NoSQL databases, also known as non-relational databases, which allows you to store and retrieve unstructured data using a dynamic schema. NoSQL is popularly used for its flexible ability to create a unique structure and can be documented using graphs, columns, or even key values. It can be organized as a data structure. The data I'm going to provide is as per ScaleGrid. The information has been collected from their website https://scalegrid.io. The data has been updated up to the year 2019. Here is the number of SQL versus NoSQL database users. You can see that almost 60% people use SQL database, whereas almost 39% users use NoSQL database. In terms of popular databases, you can see that MySQL has the most number of users, followed by MongoDB, followed by PostgreSQL, followed by others. Now comes the database engine ranking. You can see that the top 4 are still SQL based. MongoDB is in the 5th place, which is a NoSQL database engine. You can use a single database or multiple databases in your project. Almost half of the organizations from where data has been collected say that they are using a single database system, whereas the rest half are using more than one type of database engine for their products. You can combine SQL with NoSQL. In fact, 75% of the users have combined SQL with NoSQL. Here is a metric for popular multiple database type combinations. Most of the people who combine multiple database systems in their projects prefer the combination of MySQL with MongoDB. Here, the information depicts the time spent on different processes related to DBMS. You can see that the time consumed in different processes is almost equal, whether it is monitoring, managing space, taking backup, scaling, and so on. Then comes the most important metric tracked for database performance by database administrators and database-related technology developers in the projects where some kind of database is being used. The maximum amount of time is spent on tracking query response time, almost 51%. It signifies that the maximum importance is given to the point that in how minimum time the database engine actually responds to a query. Now, let us find some advantages and disadvantages of 5 top popular databases. The first in the list is Oracle. And the pros are, you will find the latest innovations and features coming from their products, since Oracle tends to set the bar for other database management tools still today. Oracle database management tools are incredibly robust. You can do just about anything you can possibly think of. And the cons are, the cost of Oracle can be prohibitive, especially for smaller organizations. The system can require significant resources once installed. It is ideal for large organizations that handle enormous databases and need a variety of features. Let us move to the next most popular item, which is MySQL. The pros are it is available for free. It offers a lot of functionality even for a free database engine. There are a variety of user interfaces that can be implemented using MySQL. It can be made to work with other databases including DB2 and Oracle. And the cons are you may spend a lot of time and effort to get MySQL to do things that other systems do automatically, such as creating incremental backups. There is no built-in support for XML or OLAP, and above all, support is available for free version, but you will need to pay for it. It is ideal for organizations that need a robust database management tool, but are on a budget. The third most popular technology is Microsoft SQL Server. Pros, it is very fast and stable. The engine offers the ability to adjust and track performance, which can reduce resource use. You can able to access visualizations on mobile devices. It works very well with other Microsoft products. And the cons are enterprise pricing may be beyond what many organizations can afford. Even with performance tuning, Microsoft SQL Server can gobble resources. Many individuals have issues using SQL Server integration. It is ideal for large organizations that use a number of Microsoft products. At fourth position, there is PostgreSQL. The pros are this database management engine is scalable and can handle terabytes of data. It supports JSON. There are a variety of predefined functions. A number of interfaces are available. And cons might be documentation can be spotty. So you may find yourself searching online in an effort to figure out how to do something. Configuration can be confusing sometimes. Speed may suffer during large bulk operations or read queries. It is ideal for organizations with a limited budget that want the ability to select their interface and use JSON. At fifth place, there is MongoDB. It is a free database that also has a commercial version. MongoDB is designed for applications that use both structured and unstructured data. The database engine is versatile and it works by connecting databases to applications via MongoDB database drivers. Pros are it is fast and easy to use. The engine supports JSON and other NoSQL documents. Data of any structure can be stored and accessed quickly and easily. Schema can be written without downtime. Cons are SQL is not used as a query language. Tools to translate SQL to MongoDB queries are available, but they add an extra step to using the engine. Setup can be a lengthy process. Default settings are not secure. So that was a brief overview of different points which you might have to consider while choosing a database technology for your project. That is all for the day. See you on our campus.